Hello everybody, this video is going to teach you about linear equations and two variables. Now, that I think deserves some explanation. First of all, linear equations, well that's simple enough. That's an equation whose graph is a straight line. And then what I mean by two variables is x and y are in the equation. An example is 2x minus y equals 5. One of the things you need to know is what is a solution of a linear equation? And a solution of one is an ordered pair, x and y, that produces a true statement when the values of x and y are substituted into the equation. So, for example, I have an equation here, 2x minus y is equal to 5, and I want to know if either one of these ordered pairs are solutions for that equation. Well, remember that here, our x is first and our y is second. Excuse me. So what I would do is substitute these values into that equation. So here's the equation, 2x minus y equals 5. For x, I'm going to put 1. 2 times 1 minus y, which is negative 3, should be equal to 5. If this is a solution. So this becomes 2. The double negative is plus 3 equals 5. 5 equals 5, which means that we have a true statement. This is a solution. I'll just put down solution. Okay, the next one, 4 and 7. Put those in the equation. Again, I'm just going to rewrite the equation though. 2x minus y equals 5. So I have 2 times 4 minus 7. Oops, what did I do that for? Minus 7 should be equal to 5. This is 8 minus 7 is equal to 5, and 1 equals 5. This is not true, so this is not a solution. Now, graphically speaking, what that means, if we were to plot this, 2x minus y equals 5, we were to graph this, a solution, so this right here, oops, this, what that means is if we were to graph it, that point would actually be on the line. So there are infinitely many solutions. Don't think that there's just going to be one for an equation, okay? That means that on the graph, that point would happen to be there, okay? Cool, let's move on. Let's graph them. So here I have an equation, y equals 2x minus 1, and I want to graph it. Well, later on, you're going to learn how to graph it just by looking at it, which is kind of cool. But for now, what we're going to have to do is we're going to have to make a table. So what I want you to do is make a table of values for x and y. Now, I suggest you use 4 values just to make sure that they all line up, because these are linear equations, which means they are straight lines, and your points should line up. So the thing that I always like to start with is I like to use 0 for x. Because if I put 0 in here, that means that that whole first term is wiped out, and y is just negative 1. If I put in 1 for x, then this first term would be 2 minus 1, and y would be 1. If I put 2 in, then I would have 2 times 2 is 4 minus 1, and I have 3 for y. Excuse me. I'd like to put some negative values in here too, so I'm going to put a negative 1. And a 2 times negative 1 would give me a negative 2. Minus 1 would give me a negative 3 for y. Now what I'm going to do is plot those points. So on x, 0, and y is negative 1. There is a point. Then I'm going to go out to 1, 1. And then my next one is 2, 3. And then my last one is negative 1, negative 3. Negative 1, negative 3. And you can see those line up really nicely. So I connect the dots, put an arrow at either end, and I graphed it. They should line up nice. All right. What about horizontal and vertical lines? Horizontal line is when you have y equals some number. So, for example, if I said y is equal to 5, what that means is it doesn't matter what the x value is. If x is 4, y is still 5. If x is negative 4, y is still 5. If x is 0, y is still 5. So in other words, I would have a horizontal line if I had an equation that just said y is equal to some number. Also, if, for vertical, if it was x is equal to some number, so if I had x is equal to 3, then in other words, no matter what the y value is, x is always 3. So if y were 0, x is 3. If y is negative 3, x is 3. If y was 3, x is 3. And it makes a vertical line. All right? I think that's pretty self-explanatory. Let's move on to function form. This is also slope-intercept form, which we will talk about later. Function form is when you have an equation and you solve for y. So in other words, it's y is equal to something. That is what function form is. So if you look at my samples here, I have 3x plus y is equal to 7. That is not in function form. In order to get it in function form, I solved for y, or I subtracted 3x from both sides. Excuse me. Notice that in the one that's in function form, I have the x listed first. You should do that, okay? So what I have here is an equation, x plus 2y is equal to 6. What I would like you to do is I'd like you to solve for y. So go ahead and try it. Okay, hopefully with this one, you said, all right, well, the first thing that I need to do is I need to get rid of that x. So I'm going to subtract x from both sides. What's left over on the left side is 2y. On the right side, then, I can't combine these because they're not like terms. So I have negative x and a positive 6. I wrote it like that because I want my variable first. Now, I have to get rid of the 2. This part is a little tricky because if you divide by 2, you divide both things by 2 here, which is the same as writing it, as this. You want to divide by 2 on every term. So now the 2's are gone, and y is equal to a negative x over 2 plus 3. But we can write this negative x over 2 in a little bit nicer form. So y is equal to, remember that negative x over 2 is the same thing as negative 1/2 x. This looks better and will be easier for you later on. So do this, because the reason this works, again, just as a reminder, because this means times x, which is x over 1, numerator times numerator, denominator times denominator, you end up with the same thing. Okay? So I'm going to rewrite this as negative 1/2 x plus 3. Cool? Why don't we try and graph this one? I think that would be a good idea. Oh, here it is. Now I'm going to rewrite this, though, because this looks ugly like that, the way that's written. Negative 1/2 x plus 3. So to graph it, again, you make this little table. And 4 values is a great way to do this. Again, I love to start with 0 because that just leaves that number hanging out on the end there. Makes the math really easy. Now let me put in 2. So if I did negative 1/2 times 2 plus 3, I would end up with 2. Then if I put 4 in there, 4 times negative 1/2 plus 3, I would end up with 1. And then if I put 6 in there, and I'm just picking random numbers for x, by the way. There's no method to this. Negative 1/2 times 6, I would end up with 0. Because, negative. Excuse my coughing, I'm so sorry. Now we're going to plot these. 0, 3, 2, 2. I said 2, 2. 4, 1. And 6, 0. Great, they line up. So that means that I did my math correctly. And connect the dots, put arrows at the end, and I've graphed it. Pretty cool? I think it is. Now, what I want you to do is I'm going to give you another one. So this time you're going to have to solve for y, in other words, put it in function form or slope-intercept form, and then graph it. Okay, so pause the video and try this, and make sure this is on graph paper. I don't want this loose in your notes. On graph paper. Okay, pause the video. All right, so first thing I'm going to do is I'm going to get rid of this 5x on both sides by subtracting. On the left side, the only thing left over is negative 2y. On the right, these are not like terms. So I have a negative 5x and a positive 6. Then what I need to do is divide by this negative 2. And again, it has to be on every term. So what I have is y is equal to, now these double negatives cancel each other, so I have 5 over 2x. And then this is minus 3. Cool. I'm going to leave it like that. I'm not going to make it a mixed number. I'm going to leave it improper. Then I'm going to make my table, x's and y's. And again, I'm going to use 4 values. I love to start with what? 0, because that just leaves that last term there. Now I'm going to put in 2. I'm going to use 2, 4, and why don't I put in a negative 1, 2? Negative 2, get it? All right. 2, if I put 2 into there, I would have 10 over 2, which is 5, minus 3, which gives me 2. If I put 4 in there, I have 4 times 5 is 20, divided by 2 is 10, minus 3 gives me 7. And then if I put a negative 2 in there, I end up with a negative 8. All right, let's graph it. So I have 0, negative 3. I have 2, 2. I have 4, 7. Well, this works out nice because I'm not going off my graph here. And negative 2 and negative, oh, I did go off my graph. I'm way down here somewhere. Okay. So if I connect the dots, you see it forms a straight line. So I graphed it correctly. Pretty cool. We'll do one more sample. Okay. I want you to write this in function form. Oh, wait, I didn't answer the question completely. It says tell if it's a function. What? I forgot to do that. Because remember that all of these points here make a relation, and we have to tell if they're a function. The way that we can do that is, well, you can look at it and say, oh, I can make this a mapping diagram. Or you can say, this would pass the vertical line test. If you took a straight line, your pencil, like this, and you just dragged your pencil across the page, it's only crossing one point at a time. So yes, this is a function. Okay, sorry, I didn't read all the directions. Silly me. All right, pause the video and try this one, and then graph it and tell me if it's a function. Pause the video. Okay. So for this one, the first thing I want to do is get rid of this and get rid of this 2x by subtracting 2x from both sides. On the left, I have 3y. On the right, I have negative 2x and a positive 12. Then I'm going to divide by 3 on all terms. And I'm left with y is equal to a negative 2/3 x plus 4. I'm going to make my table, x and y, and I'm going to use 0 because I love to start that way, and I get 4. 3, I put 3 in there, I get 2. Then I'll put 6 in there. 6 goes, and I get 0. Then I'm going to put negative 3 in, I put negative 3, blah, 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 6. Okay, graph it. I have 0, 4. I have 3, 2. I have 6, 0, and then I have negative 3 and 6. Up here, you see that they line up. It forms a straight line, and it passes the vertical line test, so yes, it is a function. Okay, that is all. Goodbye, everybody.